Okay, so let's take a look at alcohols. Alcohols can be identified by having an OH group. So when we're talking about this group, we don't call it an alcohol group, we actually call it a hydroxyl group. We name them by calling them an ol, so we'll have the suffix of ol on the end. And we can have primary, secondary, and tertiary alcohols. So if we take a look at this one here, this is methanol. And what we'll notice in methanol is that only hydrogens and the hydroxyl group are attached to that carbon. So methanol is a really special case because there's only one carbon. After that, the chain gets longer. So in this case, we've got ethanol, and we can see here that we've got 2 carbons, so making it the F. And then what we can see, the carbon that the hydroxyl group is attached to, we've got 2 hydrogens and 1 carbon attached. So we can identify that that's a primary alcohol because there's only 1 carbon chain attached to that central carbon. If we move along to the secondary alcohol, we can see here that we have a 2-enol, so we've got propan 2-enol, and we know that it's 2 because that hydroxyl group is on the second carbon. And we know that it's secondary because if we take a look at the carbon that the hydroxyl group's attached to, we can see that it's got 2 carbon chains, so 1 either side, and only 1 hydrogen. And finally, if we take a look at the tertiary alcohol, we can see here that we've got another propan, so propan 2-enol still, because we've got an extra methyl chain here. So if we take a look here at that central carbon again, we can see that there are no hydrogens attached. Alright, so that's how we identify primary, secondary, and tertiary alcohols. Some other things that we need to know about alcohols is we need to know their solubility and their boiling points. So if we take a look here, we've got ethanol in water, and you can see here that that's completely mixed. So there's not 2 distinct layers in this. Now, that's because the ethanol is only the 2 carbons, so we've kind of talked about that up here. And because it's such a small chain, the hydroxyl group, which can form hydrogen bonds with water, is able to do that quite effectively, and the water is able to surround this small molecule quite well with those hydrogen bonds forming. We take a look to propan 1-enol, and we can see here that we've got a little bit of layering, but not very much. And again, it's quite a small chain, so the solubility here is still okay. It's not as good as ethanol, but it's still quite soluble because it's small. We start getting to butan 1-enol, and we can see that distinct layer here. So because this is this is getting to be a longer chain, the water isn't able to surround that as well. So although we've still got the 1 hydroxyl group for the butanol to be able to interact with, it isn't able to interact as effectively. Solubility, as the chain gets longer, it becomes less and less soluble. So the alcohols become less and less soluble. As the hydrocarbon chain lengthens, however, so although the solubility is getting less, the boiling point is increasing because we have the same functional group in all of these. So we have the same functional group of that hydroxyl group in ethanol, propanol, and butanol. But as we increase in the number of the carbon chain, so increasing the number of carbons, we will increase the dispersion forces that are happening in that non-polar end of the molecule. So because we're increasing the number of dispersion forces and we're not changing the type of functional group, we're getting an increase in the boiling point, so an increase in the number of secondary interactions. So if we remember, the key points we need to know about boiling point is the increased number of secondary interactions increases the amount of energy required to separate the molecules, therefore resulting in a higher boiling point. Right, we also have some tests for primary, secondary, and tertiary alcohols. So we can distinguish between a primary, secondary, and tertiary alcohol by adding something called acidified dichromate. So in a primary alcohol and a secondary alcohol, the acidified dichromate changes colour from this orange colour to this green colour here. And in that colour change, it's occurring because of those free hydrogens that we talked about. So it's those hydrogen groups that are able to react. And this colour change makes other compounds, which we'll talk about with the next functional groups. But this colour change allows us to distinguish which one is tertiary. So primary and secondary will turn the same colour, but tertiary will stay orange.